Okay, so welcome everybody here in the room, welcome everybody back online. We're having a panel today about how computer science can be used for teaching and learning. We have two panel speakers, and so I'm going to do a short introduction to this subject. So when I went to school, how was education like? So this was how a typical classroom looked like. And I remember when we had to do presentations at school, we used one of these things. Maybe some of you don't even remember what this is. So presentations were not really interactive. You had to write something on a sheet and then project it. If we wanted to show a video, then the teacher had to rent the only TV we had in the school. So this was only 15 years back. Today this looks a bit different. So what we can see in schools is, for instance, that students use computers and they use tablets. And so Stéphanie Fleck is going to talk today about how you can use computer science to go even further and to make it even more interactive. And there's another subject that is really hype currently, which is MOOC and online learning. So how can you use the internet for learning, for teaching? And Jane Richardson is going to talk about this for us. And there's another aspect. So I want to remind you of the keynote or the opening note yesterday when Alexander Wolf, who's the president of the ACM, was saying that it is important to teach computer science, and this is another aspect that Jane Richardson is going to talk about. So I would like to start with a short presentation of both panelists. So if you can take a few minutes just to say who you are, where you're working today, and how you arrived there, and then later both of them will have a presentation that goes more into detail about their current work.
Switch on.
Okay.
Is it okay? Yeah. So I'm not a normal person, I think so. I have a PhD in earth sciences and a master in cosmochemistry. And after discovering that my students have no interest on my science, I decided to go to teacher training center and to start to teach science for the children, because I think that it's when you start on the early age of the development of children that they could go to the science after. During 6 years, I was a director of the teacher trainer center. And after I go in a new way of my research and go in ergonomics of learning and in psychology for education. That's all.
Good morning. My name is Jane Richardson. I'm the Senior Director for the Oracle Academy in Europe, Middle East and Africa. My background is in public and private sector around training, development, skills development, particularly those skills required by industry and for economic development purposes. And therefore, what I'm going to be talking about today is the role of computer science in the skills gap that we have globally today and in the next 10 years, and how industry is beginning to work with academia to ensure that those skills are brought into the classroom at all levels.
Okay, I need the mic back. Okay, so I want to encourage you to all participate in the discussion. You can follow on Twitter or post things we would like this, so please do. And so Stéphanie is going to start to talk about the work she's doing. So yes, you can up.
So I'm just going to present my works and my university. I'm on a French university in psychology and ergonomics laboratory, directed by Christian Bastien. I don't know if somebody knows it, in CAI department. Constricting learning situations is a very hard task. It's very difficult exercise if you want to take all the parameters that influence learning for everybody who wants to learn something. The first size is the knowledge. Is it possible? If you have to take the sense of the knowledge and the epistemological field of this knowledge, and the other size you have to take information concerning learner. That's why we design something user-centered, and I prefer to say learner-centered. And after, you have to have a reflection concerning your own experiences when you are a designer, from which way you see the knowledge and from which way you see the learner. It's important because you are not the learner. And to enhance learning, we have to have a reflection concerning which type of situation is more efficient to enhance the learning concerning children and adults. We know that lecture, for example, is not sufficient to constrict real hard knowledge because you only keep 5% of what you heard because it's only based on memory. But if you use active pedagogy, like all this part of the training, for example, it's hands-on learning or problem-based learning or inquiry-based learning. I don't know if you know this type of pedagogy. There are more interactions between the learner, and the knowledge, so it's more active. The learner constructing by herself, the knowledge. And based on this parameter, we design some principles to guide the constructions of new type of interactions with computers to enhance learning. First, parameters you have to take in. That's to construct real important knowledge, scientific knowledge. You have to manipulate and inquire your own hypothesis concerning the solution of a problem, for example. You have to collaborate and cooperate, because when you share the knowledge, it's more efficient. You have to have an active control of your learning. You have to decide what you want to do. You have to enhance your motivations. And it's an important point to do that. And the situations that you design have to be in the good place concerning the development of the knowledge of the learner. It's called the zone of proximal development, and you have to construct meaningful models. Based off these different parameters, we choose different interfaces. First, interfaces that you can freely manipulate, so we choose tangible user interfaces. And to be on the proximal zone and to construct meaningful models, we prefer 3D meaningful modeling, and so I choose augmented reality. And when you design something user-centered, we test all the models that we construct in the living lab and in situ directly in the classroom to verify that it's efficient. I'll show you some examples. The first prototype here is to learn optics and photonics. It's for higher pedagogy, and we are now testing this. I don't know if you know that. It's a Michelson interferometer. It's to learn our wave of light waves compartments. We are just now starting the test. Another type of interfaces is TG, developing in collaborations with Inria in France.
This is TG, a tangible EEG interface targeted at novice users interested in how the brain works. EEG visualizations are typically hard to understand for novice users. With TG, your brain activity is displayed on a puppet in real time. For example, you can see which brain zones are active when moving your right hand. The whole interaction takes place through a tangible interface to enhance attractiveness and to optimize the learning and understanding of cerebral activities.
So using this interface, we test it on laboratory conditions with only 12 participants, but it's clear that you can manipulate the device very freely, and so you have a particular relationships with the knowledge. It's easy to understand, so more easy than when you are a lecturer or direct courses, for example. Another type, this is the construction of the model. Another type of interface, particularly designed for children in school, to help them to learn astronomical phenomena. When children move tangible markers, they can try to understand why moon is changing daily and why they are day or night on Earth, something like that. They can interact with these devices, and so they learn more. They learn well because they test their own hypothesis. This is some example of results. You see the children that they want to know where is the first quarter of moon, for example, and they have just to move the different markers, and they have the answer of their questions. The design principles is centered concerning instructional design and user-centered design of this prototype to perform the technical specifications just before to test it in the classroom, and after we test it in ecological conditions and construct in co-design with children the device to enhance the usability of the interface, to have now the new prototype. Some example of results of the efficiency of this type of device and tangible device. Before using the interface, all the children have the same results of the tests of knowledge, and after, this part of children test with the augmented model, and this part test with a traditional model. And you see that, you see that all the children that test their hypothesis with the model have really scientific conception of the astronomic knowledge. And when we want to know that, they ask to decide to draw what they think about moons, and before the test, they think that moon is related to wolfman or to witch, for example. And after, they construct really a real scientific conception with particular representation of space. It enhances so space cognitions. So just now I want to explain to you how and why augmented learning environments enhance learning very quickly. If you see, for example, different strategy that children use to understand why moon phases are changing, you can see that if you use your own strategy, gestural strategy, many strategies are recognized. And all of are particularly efficient, except for the last one. And pupils control their investigation. They have the decisions, so they construct what they want to know, not what the teacher wants that they have to know. Just after, their knowledge are more construct, more efficient. This type of interface support cognitions, because you have particular emotions during this experience. You are happy, you have a personal experience. You are motivated, and it depends on the device, but you have immersive influence, or for TG, for example, you can have identifications between you and the device. So you have your relationships between you and the knowledge. Augmented reality and tangible interface support sense, proprioceptive and visual perception of the world. And so you limit the illusion of perception, so you have a more construct representation of the world, not through a screen, but in the physical environment. It supports memory, and if you couple augmented reality and tangible interface with particular technique of education, science, for example, inquiry-based learning, you can solve problems. And so you have an active control, and you mobilize praxis, for example, your representation of motor motions of your body. And so you enhance constriction with with your body, not only with your mind. Just an example of my work. And the future challenges of the work in education using computer is enhancing skills and supporting professional activities of teachers. Why? Because if teachers haven't information concerning how to use computer, or the advantage or the limits of the computers, they have difficulty to introduce the device in their classrooms. They stay with the traditional tools. But the world is changing, computer is everywhere, and children are more efficient than their teacher now. So we have to support the teacher training to help them to support the children with the computer. Another point is raising the level of education for all the differences, for all the people, with the aim that all the people have the common base of knowledge and constrict more than knowledge. They have to constrict social abilities and personal abilities and skills because they are citizens, not just men or women. They are in a social environment. We have to take with a lot of energy, tackling early leaving from education and training. And for example, it's not a woman problem. It's a man problem because during the college in France, for example, there's all the young persons who leave the school are boy, not woman. We have to construct an inclusive school because now handicaps, allophone, I don't know the word in English. How do you say allophone? Allophone? People who don't speak the native language.
Foreign
language.
Speakers, yeah.
Foreign speakers are very important in the classroom. This is very difficult to construct something for all the differences in the classroom. It's important that you take in consideration the heterogeneity of the people faced to your device. And the last point is an opening field. It's developing adults' education and training in higher pedagogy, of course, but for all the people, for all the old people. So we have a large field to construct something for the future in school, and it's a great challenge now. Thank you. To you.
Now we will have Jane Richardson presenting about Oracle's perspective. We can't stream the slides, so the people in the room can see the slides. The people online, unfortunately, cannot.
Thank you.
You have to, okay.
Good morning, everybody. I'm Jane Richardson, as I said before. I am the Senior Director for the Oracle Academy program, which is Oracle Corporation's academic program for schools, excuse me, universities and colleges globally. And my particular region is Europe, Middle East and Africa, where I work with ministries of education across these regions, directly with universities, and in the K-12 learning space. And following on from Stephanie's presentation, I think we have a lot in common in terms of what industry is trying to do to support academic learning in computer science, but also recognizing the modalities of learning that are more important for students in terms of the pedagogy, in terms of collaborative learning tools, in terms of those 21st century learning skills that all of us at whatever age need in terms when we move into the world of work and into the world of even further education, in terms of communication, collaboration, learning through doing, learning through project-based learning, and also learning through sharing of assessment and peer review. So within Oracle, we are the second largest software company globally, second largest cloud company globally, but Oracle Academy, who I represent and speaking about today, is part of our corporate social responsibility program. So what I'm talking about today is everything that we do, we provide at no cost to a university, to a college, or to a school. And our focus is very much on allowing learners to get the access to the tools that are being used in industry today. Why are we doing it? I've got a percentage up there which refers to actually global demand in terms of computer science skills in the workplace into 2015 and 2018 and beyond. In terms of the number of professionals, the European Grand Coalition for Digital Jobs, which was launched 2 years ago, predicted over 900,000 ICT jobs unfulfilled by 2015 and beyond. But more importantly, those jobs are going to be in every industry. I'm not talking about the IT industry. I'm not talking about working for Facebook or Google or IBM, etc. I'm talking about industries like the banking sector, the oil and gas sector, the media sector. These industries are desperately in need of people with computer science skills, and they are gender neutral. Obviously, there's been a lot of discussion in the last couple of days about, the role of women in the ICT industry. And I'm here to say that our industry is neutral because the skills that you have are in demand. And therefore, there was a lady speaking yesterday from Facebook who basically said, let your work show itself, Take that gender off the table. And one of the things that we want to do within education is to take gender off the table by introducing computer science skills to students at a very young age, so it becomes part of core learning like maths or language, etc. So it doesn't become a boy-girl situation in terms of I'm choosing computer science because of my gender. The skills that are needed within the industry are huge. And therefore, whatever we can do within academia to make sure that these skills are being developed within the classroom is very important to us in industry. We focus on early programming, and there will be a workshop later today which will showcase a program called ALICE, which is one of our early learning programmings for young students. So we will work with educators who are teaching students from the age of 8 onwards. We provide academically credit-leveled courses that can be used directly into curriculum and into classroom, but the core is all about giving the educators, giving the teachers, and giving the faculty the tools they need to be able to deliver in the classroom. In terms of continued professional development, that's what we're all about, the continued professional development of teachers and faculty so that they can actually be bringing into the classroom the current skills and the tools and learning that industry needs when their students move either into higher education or into the workplace. For our younger students, I mentioned we have a tool called ALICE, and my colleague is in the audience today. He will be running an ALICE workshop later today. And that is where we're introducing very young students to the concept of object-oriented programming through the use of 3D graphics, storytelling, story building. But it is a tool, a programming tool that can be used in any part of the curriculum. You can be using this tool in a science class, in a history class. You could be doing an animation about the planets as part of, a geography class, for example. So therefore, using computer science tools in the classroom, cross-curricular, whilst also demonstrating that everybody can start to learn to code. Everybody can start to learn to be part of the programming world. Greenfoot is a similar program developed by the University of Kent, which uses similar tools, but computer gaming, to start teaching Java programming to young students and as an introductory tool to students that have never been exposed to programming. In terms of what we do in the wider scope in universities, 2-year colleges and schools, we deliver programming tools to teachers and faculty in the areas of Java programming, database development, SQL and PLSQL skills. SQL being one of the key skills that underpins the Internet of Things, underpins cloud computing. If you're talking about cloud computing, you're talking about developing your skills in database development and maintenance and management. You need these skills whatever part of industry you're going to be working in. We deliver in a blended model. Not everything we do is online. We believe in face-to-face training because culturally it is different for different people. We also believe that we should offer the opportunity for self-study for our students. We don't do MOOCs per se, we do self-study online, but we also do instructor-led virtual training, which is actually mentored and monitored. So our student faculty are never left on their own to be learning themselves. We provide a whole range of free software tools, development environments for not just our faculty and our teachers, but we provide them to the students to use to either self-study or to start to practice within various development environments. Mainly open source, mainly freely available, and at no cost to any individual to participate. We have learning libraries online where we have things like big data boot camps where we actually show how big data is used in real life, using the example of a flu pandemic and how the tracking and tracing globally of data in that environment is actually used in a productive sense. And we also work with community education projects globally to allow that to be spread to different regions in the world. We provide to any university or school that works with us free academic licenses to all of our software tools so that students can start to learn how those software, either application development tools, are actually used in industry, and you can start to play with them while you're in the classroom. And in terms of the larger community, I don't know if anybody here has heard of the Raspberry Pi. The Raspberry Pi Education Foundation has really basically developed a $35 computer. It's basically a circuit board that you can connect to a keyboard and a monitor. You can create a computer anywhere in the world for around $35. What we've done is actually partnered with them to create a project which is all about gathering weather data globally, providing 1,000 schools globally with a free kit that students can put into the classroom. They can gather weather data, but more importantly, they can put that data into a single database and start learning how to interpret that database, how to pull data out of that database, and start developing these SQL, structured query language tools, whilst doing a completely different kind of classroom and geographical experiment. So it shows that, you know, we're not talking about having just using tablets or computers in the classroom. It's more important that the content and what's being taught using those devices are the much more important thing as far as we're concerned in terms of developing that computer science skills that are in huge demand across the industry today. Thank you.
Thank you, Jane. So a panel is all about discussion, so we want to have a discussion now. There's definitely going to be some time for questions from the audience, but I want to start with a question to get them started, or maybe it's a question to sum up in one sentence or in a short phrase. For you, what is the most important contribution of computer science to education and learning today?
Probably the possibility to change the relationships between the children and the knowledge, for example. You see the world with another eye, with the computer science, with another possibility of opening the field of access to knowledge. It's more large, but it's probably more, there's a lot of information, but we have to help the learner to select the informations, for example. But computer science is now the best friend of the teacher, I think, because it's like a new teacher in the classroom, another one. If you think the computer science like that, I think it's more efficient. But we have to be aware concerning that computer is not the only solution. It's the solutions when in the reality it's impossible. If you can do something really, don't use computer.
I think I would agree with a lot of what Stéphanie's saying there. It's not necessarily about computer science replacing any other learning. It's about using the tools intelligently within the classroom, either to actually teach the computer science skill sets that I mentioned in terms of programming and database skills, which are hugely important regardless of what industry you actually are involved with, because the world is revolving around big data these days. You cannot move without hearing about the Internet of Things and cloud computing. So therefore, you know, that all has at its essence and its core computer science and the understanding of how to analyze data. But as Stéphanie said, it's absolutely right. There's no point in having data unless somebody knows how to analyze it. And therefore, there are other skill sets that are so important in terms of financial skill sets, accounting skill sets, scientific skill sets. They will be using the same tools to collect data, but the skills that they bring to analyze it will be completely different. So it's getting that balance of skills. The job of a data scientist was not heard of 4 or 5 years ago, and now you're seeing regularly those kind of roles being asked for in different industries across the world, because everybody understands they're going to have to analyze data. I think for students in the classroom, they must be comfortable with computer science as being a core part of their curriculum. Everybody talks about the STEM subject matter. It's very important, but we need to think about computer science and programming as another language, another tool that, as I said at the start, could be very much gender neutral. If you learn this from a very young age, you don't think of it as a boy or a girl choice in terms of computer science programming as a skill. It's just something that everybody does and uses in a very different way.
That is a very nice transition to my next slide, which was the question: how does learning of computer science and technology influence women in particular? Or, so maybe Jane, or I don't know if you want to add something, but maybe Stéphanie, you have an experience, or also your experience when working with children. How does their gender influence the way they interact with the technology?
The answer is it's not the same if you have only young learner and oldest. With the child, there's no difference with the relationship between computer and children. If you are a girl or a boy, computers are everywhere in your environment, so the relationships is easy. It's not the computer the difference, it's the content that you mediate with computer that make the difference between gender when they are young. It's the society is like that. It's not good, I agree, but it's like that. Boy prefer dinosaur, prefer space information, something like that, and young girls prefer animals, biology, or something like that in science, or language, or something in social relationships. We have to change this using computer. But it's the rule not of the computer, it's the rule of the designer of the content. And when you are oldest, it's not the same, because coding, for example, boys know that it's normal for a boy. For young girls, it's a teenager, it's not the same problem. They have more difficulty because it's associate with mathematics. Coding and mathematics are very near, so they think that it's not their place. But with the device, there are no difference.
I think we see that stereotype of boys are about coding and girls tend to go to a different part of the STEM scale. I think you're right. The content is all important because what you're exposed to is going to give you a bias towards what you're going to learn in your long-term academic career. So therefore, some of the tools that we're particularly keen to take forward, the ones that I mentioned earlier, Alice, developed by Carnegie Mellon University, it's all about creating animations using object-oriented programming skills. So it's about storyboarding, it's about content creation, it's about collaborating in teams, and it's very popular with girls because it's creative. And I think one of the things we need to do as an industry is get this message across that programming, computer science is one of the most creative skills that anybody can have, because from absolutely nothing you can create something that is almost living and breathing and functioning. So therefore, you know, as far as girls are concerned, we see a lot of girls' computing clubs coming through. We're seeing more girls coming into the industry. And I just generally think that let our work speak for itself. Our industry is pretty neutral. You know, there's not a huge gender bias in the industry. The skills that people have are in demand. It's regardless of whether they are male or female. But I think you're right. We need to get that knowledge further down into the school so that younger students age 8 and above are just seeing this as part of their DNA. It's not something that they make a differentiation about.
Another remark, in higher pedagogy in the university, during the last survey I've done, I remarked that teachers who are women use more computer to teach and to expose their learner to different devices. It's not the same for the men. Men stay on their traditional skills. Do not open the tools to online learning on tangible devices. I don't know why, but it's a fact.
This is actually an interesting point also. I wanted to dig deeper in this. What do we need to provide the teachers with so they can make use of this technology? Because when they have been trained at the university years ago, they didn't learn programming, they didn't learn how to use a Raspberry Pi or the augmented reality things. So what do we need to do in terms of enabling the teachers to use this technology?
You want to answer?
Speaking purely from the perspective of Oracle Academy, that's really what we're all about. We're all about making sure that teachers get exposed to these, either the new tools or the new technologies. Our investment is in the teacher at all stages, whether it's somebody coming through teacher training college, the young teachers who maybe come from the Facebook generation are more open to using those tools in the classroom because it's a natural extension of their normal life. But also we have worked with many teachers who have never been exposed to computer science. We have shown them how to use those animation tools, these gaming tools, cross-curricular in the classroom. And yes, there can be resistance, but the resistance is through fear and through not having any background knowledge to using these tools. But very quickly, when those tools are introduced by the teacher into the classroom, the students take over. The students immediately take over, and then that fear, that barrier between the teacher and the student comes down very quickly because they're actually beginning to learn together. And I think the investment is continued professional development for our teachers as we move forward.
In my main center, because I'm working in a teacher training center, we try to co-construct the tools with the teachers. It's their professional skills to construct learning support, and now it's difficult for them to put these skills using computers. They learn using paper or books, something like that, but it doesn't learn to use computer. So we add a part of course to construct the content and to construct the tools too. I think it's important like that to introduce this part of formations during the teacher training. And another part is to change the mentality that teacher thinks that computer could replace the teacher. So they have fear about that. That MOOCs, for example, is the best example of that. You can have a course without teacher. So many teachers doesn't like this.
But I would say that different MOOCs have different success rates, and so there can be up to 80% attrition rates from MOOCs because of that very part, that there is no teacher, there is no moderation, there is no mentoring, etc. What we tend to do within our teacher training is either face-to-face or a blended model. So it's partly online and partly face-to-face, because I think you're right, culturally people need to have that mentoring, and in culturally people sometimes are not willing to look at virtual learning because it is isolated and it doesn't let you network, it doesn't bring you into a group. So I think a blended model, depending, you know, on the experience and the culture, is important.
Okay, thank you. I think we can take some questions from the audience at this stage. Jessica is going to pass around the microphone.
Hello, my name is Clara. I lecture at a university in Madrid, in Spain, and I'm teaching first-year students. And all these things that we have been talking about today, I find them very interesting. I think in 10 to 15 years' time, hopefully we will get in our universities students that have been working with Alice, or now Scratch is also very popular. So students that have some knowledge, some understanding of programming. But what we have now is, so before this 10 to 15 years, the students that come now to our universities, most of them have no knowledge at all about programming, because that's what I'm teaching. I'm teaching programming to first-year students. And so one thing is, okay, there are these languages like, or these tools like Alice or Scratch aimed to younger kids, but what about those that come to university and we are still teaching them the old style programming? Yeah, is there any tool, language that is good for these students to because so we start with Java, and we see that a lot of the students are abandoning our courses. We have groups of 70 people that start and only 20 finish the course because they get lost in all the Java things. And I always try to put concepts first, ideas first, how you program, and then, okay, let's now bother about the syntax. And we try to use Dr. Java. We try to teach basic programming things without getting the objects in the way. That's almost impossible with Java. So it's, to me, it's a mess. And I know at some universities they use other programming languages first and then they move into objects. But we are not doing that because we have too little time. We want them to be exposed to the syntax. I don't know what's best, but I struggle with my students. This is yeah, I would like to hear what you think about this.
And what you're describing is quite a common situation. I mean, with universities that we work with, you know, globally, on average, around 30% of the students that come into the computer science course in first year at university have never been exposed to programming. And it's actually quite interesting because tools like Alice and Greenfoot are beginning to be used as almost bridging tools and remedial tools for that cohort of students who need to get up to speed in terms of their programming skills because they've not come from school with that. From our perspective within Oracle Academy, we've obviously very much focused on the Java, and we have actually recently introduced new academic curriculum which we give to universities, which are foundational courses in Java and fundamentals courses in Java, which can either be self-study by the student offline, because they're hosted learning tools, but they can also be used by you as an educator to take modules of that into your curriculum directly. So I would love to speak to you after this to give you some information on how we can support you with that, because you're right. The problem is further down. The problem is at the schools, getting the students coming out with those core skills so that when they come to you, you're not having to start really from a remedial perspective to bring them up to speed. So we do have a set of tools that can support you to do that.
Another question.
Hello, my name is Johan Snyder, and I'm a master's student here at Uppsala University. Last year I took a course here called Computing Education Research, and for the project for that course, my group took surveys of students here at Uppsala studying to be teachers, about I think we had 35 people respond, about half were Swedish and half were international students. And the two biggest questions we asked was, how important do you feel computer science is to you being a teacher for the next, and these were also mostly second, third, and fourth year students in the teaching program. So we asked them, how important do you feel computer science is for your career and for you to be teaching? And has your program prepared you in any way to teach computer science? And the result we got from that small sample was everyone said that computer science is extremely important and that they didn't have hardly any classes preparing them to teach computer science. A lot of respondents cited, oh yeah, we've used tablets and we've used smart boards, and it was more focused on using technology in the classroom as opposed to, which I'm sure the problem you guys are familiar with. So my question is, have you seen any countries or universities put a really strong emphasis in teaching the people who will be teachers now? Have you seen any countries or universities put an emphasis on teaching them computer science while they're in the program and while they're getting in, so that they can teach computer science to students in the next 20 to 30, 40 years?
Yes and no is the answer to that question. From an Oracle Academy perspective, we work with business schools, we work with MBA students, you know, we work right across the board. You know, we have things like workshop in a box sort of thing, you know. So we have those tools to allow those students who are cross-curricular to be exposed to computer science skills. From a Ministry of Education perspective, I won't mention specific names, but we work very closely with ministries of education right across Europe and globally, where we are working directly to support teacher training in the teacher training colleges before those teachers come into the schools, so that they are actually being exposed to those programming skills. And as I say, it's not the device, it's the content that's important. We can all have a tablet, we can all have a smartphone in the classroom, but if nobody knows how to be a creator as opposed to just a user, we're doing everybody a disservice. So this is where we are very firmly placed from an Oracle Academy perspective, is to train the teachers, to educate the educators, so they are bringing those skills into the classroom from a very young age. And we have many universities that we work with where we have actually taught their faculty, but not the computer science department. We have been teaching the faculty in the business department, in the science department, because everybody's going to be, as I say, be using big data at some point to analyze and understand, you know, some part of the world around them. So a lot of our educator training is not necessarily to the CS department, because they already know how to do this. Is actually the other departments that we want to get more involved in, who, if you're in marketing, if you're doing an MBA, you know, if you're in a business school, you're going to be exposed to this. You're either going to be exposed to an application that's used in an industry, whether it's an Oracle one, an SAP one, an IBM one, etc., etc. But whatever industry you go to work with are going to ask you to have some degree of computer science skills. As I say, the data scientist role did not exist 5 years ago in a CV or in a job search. And the data scientist role is not to be a specialist in computer science, it is to be a specialist in that sector or field of study, whether it be medicine, whether it be, you know, the oil and gas industry, but they have a core skill of understanding how to use, analyze and manipulate data, or create the programs to do that. So that's where we are very firmly focused.
Maybe I can add something. So I'm myself actually a researcher in computer science in France. And in France, the Ministry of Education, I think, has observed that it is quite urgent to introduce computer science into high school. And so they're actually approaching the universities and the laboratories in computer science, so that the researchers and assistant professors help train the teachers who are already in school, so they can learn more quickly how to use computer science. And I know that the French Association of Computer Science, so who regroups all the associate professors, and researchers, is working on a program how to do this kind of quickly. But I think the solution is not yet established.
That leads very nicely to my contribution and question. It's, in the UK, there was a year of code, and it was expectation for teachers to well, to learn to teach code, and you find this big resistance because the diffusion of innovation as well. You are not being in computer science doesn't necessarily mean to code. It's developing several digital literacies, which is like understanding, being user of, accessing, having even a citizenship of how do you behave in the web, how do you interact with computers and computer systems, and it's not just coding. And I think we actually disengage people when you introduce coding very early without exposing what is much richer than that. My question is how would you, or what would you propose to do when you're supporting educators to do this development of digital literacies in the classroom?
I mean, I think the short answer is really the investment in teacher training, the investment in educator training, whether that's coming from a government side through a Ministry of Education, or whether it's coming through a public-private sector partnership. For example, within Oracle Academy, we work in 96 countries across the globe. We trained over 9,000 teachers last year in a range of areas, whether it was database, SQL, Java, etc. So industry is participating. Google, Facebook, IBM, Cisco, they all have education programs. Everybody has a piece of the jigsaw to build the bigger picture, because we all have a stake in this as well. We want to make sure that our customers, our partners, the industries in which we operate are all having that successful outcome in terms of the skills that are coming into the industry. So everybody is prepared to invest in teacher training, whether it's at the teacher training college level or whether it's in faculty level already in university.
There's another problem. Oh. Is it okay? No? There's a problem. It's good if you develop some courses concerning that, but another fact is all the students coming to teacher career doesn't come from science. They come from human science. So computer is very far from her because majority of teachers are a woman. And the gap between understanding that we have to use coding and learn coding and teach coding, and the image that she adds from their job is very large. Most of the women in my teacher training center doesn't think that they have to teach code. Most of her think that they just have to do the educations, the base of the educations. Not coding. It's very techniques. It's not for her. You see, most of the teacher in my center coming from a foreign language field, or French, or psychology, or science applications, something like that, not from science. So it's very difficult to explain to her that it's normal. It's you have your formations only during 1 year. You have to learn to teach mathematics. You have to learn to teach French. You have to learn to teach sciences, geography, history, another language. It's very hard, and if you add code on that, it's very awful for her. And so it's very difficult. I think it's better to start earlier. Start when in the first year of the university, to have in all the field of the formation in higher pedagogy, not only in science, not only in computer science, and after you have teacher with these skills.
I would say a yes and no answer on that as well. Clearly, there are going to be individuals where, when they're going into teacher training college, that this is not going to be one of their core skills. That, they may not want to do that. But I think what we can show teachers is that they can be used as tools cross-curricular.
Yeah,
So it's not just about, you know, we're going to teach you to be a coding teacher. It's actually, we're going to teach you how to use a particular technology tool in a history class, in a science class, you know, in a geography class, but with an underlying learning of basic programming. So you're kind of covering both at once, and I think that's possible.
I'm totally agree. I'm totally agree, but the program in the university is not think like that. You have, we do not constrict the program in project-based learning. So we separate mathematics from history, from language, from like that. We put all the lessons in a box, separate one by one. So it's difficult to make links between that. You probably using codes, it's the solutions, but for the moment, I think that university is not in the good way for that.
Are there any more questions?
Hi, my name is Noor Hamdan, and I am coming from RWTH Aachen University from Germany. I'm doing currently my PhD there, and we started a program that was not funded enough, so it stopped, but the program was about engaging girls to make 3D objects and print them so they can wear their own designed jewelry. And it had a lot of hype between the girls that around the university, and we invited girls from the schools, not university women, and we asked them if they would be interested in learning just a little bit of coding, just to print this new, unique jewelry that they designed themselves. And it was a very exciting moment for everyone. And how to learn to use the milling machine, 3D printer, laser cutter, everything. They were like, in one day, they could grasp so many techniques just to get their product out and be proud of it. I wish we had more funding to support that more. But what I wanted to share is that in this experience, we learned that peer learning was more interesting for them than a teacher being standing there. They wanted to try everything. Just tell me how it works, and I will figure things out. And when I have a problem, I'll come to you. And this worked perfectly for like the short time period it ran. So maybe this is a program that this is a model that we can implement further, make people help people. And programmers, I don't know, I can generalize this, but programmers, when they have a skill, they're so proud of it. They are willing to share. They want to teach you, and they want you to get into the group of programmers. So yeah, maybe this is a model. Thank you.
That's great. No. Sounds wonderful. I'd like to know more about it, and I think you're right. The 21st century learning skills, you know, should be beginning to be embedded in all teaching. You know, the communication, the collaboration, learning by doing, learning by peer review, learning through collaboration and through project-based. And I think we're seeing more and more of that cross-curricular in the last 15 years, because I used to be, about 15 years ago, I would be working with project-based online learning tools, and there's a huge resistance even to kind of sharing that learning amongst groups of students, and that's changed quite radically when you look into a lot of classrooms today. You see the teacher in the center of the classroom as opposed to like me out to here. You're seeing the teacher being in the center of learning, posing questions, as opposed to being the person that is just parting information. It's collaboratively learning. But you're right, you know, peer learning is so much more efficient. Yep.
To wrap up, because I'm sorry, I've seen there's another question, but we're running out of time. So let's end on this positive note, which is a nice point, I think. Let's thank our speakers. And then have a happy lunch break.
And just workshop, 1:30, round the corner, and you can actually see some of these tools in action. Come along and have a look. Thanks, it was very Thank you.